Recently, there's been a lot of news about the P1 variant out of Brazil, and we've been seeing stories about how there's been a lot of reinfection in the city of Manaus, which was hit hard in the first wave, and it looks like most of the reinfections are this P1 variant. And I wanted to talk a little bit about the P1 variant and also about why I think maybe I was wrong about how the epidemic will end. In the previous video, I was thinking that maybe the virus would continuously mutate and stay ahead of our vaccination efforts, and that there would be a constant battle of us chasing the mutations and evasion from the virus. But now that we're in March and there hasn't been any new major variants of concern detected since January, and genomic analysis of viruses has increased, and we've been sequencing a lot of the infections all over the world. There hasn't been any new variants of concern that are significantly different. You know, the two major ones that are concerning are this P1 variant and the South African variant, the 351 variant. The UK variant, the 117, was kind of interesting in that it spread a little faster, but did not seem to have any difference in immune evasion like the UK and the P1 variant. So this is a paper that I will link. It's a not peer-reviewed report out of Manaus. This was back in January, and so basically, this is all the mutations in this variant. And what you'll notice is there are a few repeating mutations: the 417, the 501, and the 484. The 484, remember, this is the important one that gives you some immune evasion most likely, and the 417 and the 501 are thought to increase the binding avidity of the spike protein to the ACE receptor. And so this paper talks about convergent mutation. And what this means is that there's variants of the virus that have developed independently in different parts of the world, but they seem to all be having the same mutation, and they get the same mutation independently. They're not related to each other, but they come to the same mutation, which means that they're converging on the same things. And so the fact that they're converging on the same thing, this table shows it a little bit better. So these are the three major variants of concern in the world right now: the P1, the 351, the 117. And you'll notice if you look at these, the 501, you see the 501 in all of them, the 614, and then the 44, 44, and the 417 are conserved within these two variants. So it looks like these are the important mutations that help drive infection rate and also immune evasion, and there haven't been any new variants, even though we are looking for them and sequencing them in the past several months. So maybe this is all there is. Maybe there aren't any more ways that the virus can evade things other than these mutations. And if that's the case, if this is all that's possible mutation-wise without sacrificing how well it's able to infect our cells, then if we find a vaccine that can take care of this variant, then we can theoretically end the pandemic through vaccination. And so, yeah, if there's no more mutations possible that can evade it without sacrificing its function, the virus's function, then there is hope for ending it via either herd immunity or naturally, or herd immunity via vaccination. So I think that's encouraging.